Okay, good morning. Good morning, good afternoon, good evening, whatever time it is, wherever you are. So today I'm going to show you guys about graphing hyperbolas. And I took a little bit of, Pepper. Pepper thinks it's playtime. All right, so that was my cat Pepper, just in case anybody was wondering what that flash was. Okay, so I already wrote down some things here, and let me start walking you through some of it. The first thing, this is chapter 10-5 on hyperbolas. Hyperbolas have some similarities to ellipses. They both have two equations where you're really just switching whether the x squared is on the left or the y squared is on the left. So if I take the one on the, for this one for a minute, where the x squared is over the a squared, this is what's called the horizontal hyperbola. It has vertices at plus or minus a0, which means that the vertices are just on the x-axis. Foci will also be on the x-axis, and we use the formula c squared equals a squared plus b squared to find foci where needed. Asymptotes would be y equals plus or minus b over a times x, which means the slope of that asymptote is going to be b over a plus or minus. So I drew these graphs. I think will be helpful. You want to copy these down. The blue curves are the actual hyperbola. The red lines represent the asymptotes, and I put green points there. Just kind of estimated where the foci might be. The foci are behind the vertices. The vertices are actually right on the axes. And they're the point that that hyperbola hits. So you can see those are rough graphs. And the only things I usually use with the graph is I make sure that the vertices are correct, and the asymptotes are correct, and then I just kind of sketch the hyperbola in there. So here's the other one. It's almost the same thing, except the y squared comes first, minus the x squared over b squared. They're both equal to 1. That's standard form. I didn't write that. Probably be good too. I'll show you a couple of problems where they're going to ask you to switch the form around. They'll give you something in non-standard form and ask you for standard form. So you can see the major difference between these two types of setups are, which way the graph goes. The one on the left is called a horizontal hyperbola. It's horizontal because it hits the x-axis, and it goes more or less, it's on the left and right. And then there's the vertical hyperbola, which goes through the y-axis, you can see there's one on the top and one on the bottom. However you remember, it's good to keep them straight. Okay, and you can see that they both have similar slopes on the asymptotes, except one's flipped upside down. But it's really the numerator is always going to be the y value. What's underneath the y in this case, you can see up here. Since a squared is underneath the y squared, that's the numerator in the slope, and then b squared is underneath the x squared, so that's the run. Rise is up and down, run is left and right. So the rise would be the up and down, which is underneath the y squared, and the run is underneath the x squared, which makes sense because, the x is the left and right and the y is the up and down. Anyway, those are things that help me keep some of that stuff straight. Okay, so I'm going to move on. You guys can hit pause if you need to copy that stuff down. First thing I'd like to show you is this problem here. And I put a graph because I'm going to graph it eventually. Number one is a hyperbola centered at 0, 0. That's really the only kind we're going to be looking at is the ones that are centered at 0, 0. Has vertices plus or minus 4, 0. And one focus at 5, 0. And I got a couple parts here. A is write the equation in standard form. And B will be sketch the hyperbola. Put that over here. B, put it right above the graph. Sketch the hyperbola. Okay, so A. Let's see. I'm going to use that equation, c squared equals a squared plus b squared. And A is going to be 4. And B is going to be, C is going to be 5. Excuse me, the focus is always C. Okay, so if I plug those numbers in, I get 5 squared equals 4 squared plus b squared. Notice how it actually wouldn't have mattered whether I plugged it in for A or B, because you're going to square it and add them together. You're not really doing anything different, which would give me 25 equals 16 plus b squared. Subtract 16 from both sides, and I get b squared equals 9. Therefore, b equals 3. Okay, so if I plug this into my formula, I got the x squared over something minus y squared over something equals 1. Now, how did I know the x squared went first? Well, up there in that equation, it's the vertex is 4, 0. 4 is on 4, 0 is on the x-axis. Therefore, if the vertex is on the x-axis, the x squared goes first. Okay, which also means this is going to be a horizontal hyperbola because it's going through the x-axis. Okay, now, so a is 4, which means that goes underneath the x squared. B is 3. Goes underneath the y squared, so this would be one way you could write it. If you wanted to write x squared over 16 and y squared over 9, you could. Equals 1. Okay, so that is the equation that I'm now going to graph, which means the slope of that, those asymptotes, maybe I should write what the actual equation is for the asymptotes. Rise over run. Rise is what's under the y, which is 3. Run is what's under the x, which is 4. So it's going to be plus or minus 3/4 x. That will be my two equations for the rise over run. And I'm going to start with that, actually. I like drawing my asymptotes in there first, which means it's got a slope of 3/4. So I'm going to go up 3 and over 4. And we'll run out of space, but that would be somewhere over there. Let's see, left 3, down 4, 2, 4. Okay, so I'm going to draw them in. Ooh, something went wrong. Okay, so back to, I had the rise over run wrong. I did a run over rise, so this should look a little better. Maybe not perfect, but should be better. All right, so there's my asymptote. There's one of them. The other one is going to go the same slope, except it's going to be negative. So up 3 over 4, down 3, right 4, and that should give me my asymptote over here. Asymptote the other direction. Okay, and this is going to go through 4 on the x-axis. 1, 2, 3, 4. Negative 4 is over here. So those are my vertices, 4 and negative 4. And now I'm just going to kind of sketch in my curve. It's going to go like this. It's going to approach both of the asymptotes, but will actually not ever reach them. And there it is, okay? Now, this is probably a helpful thing I'm going to show you. If I was to take that equation, you know, x squared over 16 minus y squared over 9 equals 1, and I wanted to put it in my graphing calculator. Your graphing calculator needs y alone. So, you know, if I went and I took, you know, 1 and I subtracted x squared over 16 from both sides, I'd get this equals a squared. You know, and change all the signs around here, so then this would be negative 1, and that would be plus x squared. Multiply everything by a squared, I would get a squared times x squared over 16 minus 1. That would equal y squared, and then you take the square root of both sides. Oh, a shouldn't be. A should be 9. It's a 9, not an A. My scribbly writing. Okay, back to that. So if I took the square root of everything, square root of 9 is 3. This is going to be plus or minus the square root of x squared over 16 minus 1. And that would be something you can punch into your graphing calculator. Which I actually did on this thing over here. Yeah, so here you can see I graphed it on the Desmos. You can see the equations on the left. I also put in the asymptotes there. You can see those. But you know, this graphing calculator can't do plus or minus. At least I couldn't figure out how to do it. So I did, you know, 3 times the square root of x squared over 16 minus 1, and then negative 3 times x squared over 16 minus 1. Okay, so that's how I did it on the graphing calculator. So that's how you can do it that way. Okay, so back to this. Why don't you try one, since I just did all that. Number 2, you try. Hey, what is the standard form of hyperbola with vertices 0 plus or minus 4 and foci 0 plus or minus 5? Okay, so you should hit pause, and then B is going to graph it. I'm going to have you graph it also. Right, you should pause and then come back. Okay, so first part, if I took that equation c squared equals a squared plus b squared, Pythagorean theorem, c is 5, I'm going to use a is 4 plus b squared, which means 25 equals 16 plus b squared, and if you solve that out, you get b equals 3. Which means my equation is going to be y squared over 4 squared minus x squared over 3 squared equals 1. Therefore, it's y squared over 16 minus x squared over 9 equals 1. Sketch a graph. I'm going to do it on the graphing calculator. Okay, so here's what the graph should have looked like. You can see I put in the asymptotes. The slope will be 4/3 and negative 4/3. And the equation, when I solved it for y, was y equals plus or minus 4 times the square root of x squared over 9 plus 1. And that's what your graph should look like. Okay. Back to this. All right, number 3. So that's it for the graphing part. That's what I want you to be able to do. But there are a couple other things I'd like you to do. The first one is what happens if they give you an equation not in standard form. What are the vertices, foci, and asymptotes of the hyperbola with equation? Nine y squared minus 7x squared equals 63. Okay, so you got to have equals 1. So the first thing I'm going to do is just divide everything by 63. Okay, and I'm going to write down my fraction. So that gives me 9y squared divided by 63 minus 7x squared divided by 63 equals 1, which is good. Now I can reduce that fraction a little bit. I can, 63 goes into 9 7 times, or 9 goes into 63 7 times. I think I said that backwards. So that would be y squared over 7. And 7 times 9 is 63, so it's x squared over 9 equals 1, which means, rewrite this over here, if I wrote it in square root form, took the square root of the denominators, I would get y squared over the square root of 7 squared minus x squared over the square root of 9 is 3 squared equals 1. Okay, so what that means is A equals the square root of 7 and B equals 3, which means I can find C, which will help me with the foci. So the C squared equals the square root of 7 squared plus 3 squared, which means C squared is 7 plus 9, and C therefore will be the square root of 16, which is 4. Okay, so let me write down what I got. I can tell you the vertices are 0 plus or minus the square root of 7, and the foci are 0 plus or minus 4. Okay. I can also tell you that the asymptotes are y equals plus or minus the square root of 7 over 3 x, which means the slope, both asymptotes will be, square root of 7 over 3 or negative square root of 7 over 3. Once again, the slope is the rise over the run. In this case, the rise is the square root of 7, what's under the y squared, and the run is what's under the x squared. Taking the square root of both of those, and that gives me my answer. And of course, that would have been a vertical hyperbola. All right, next. You can try a very similar one. Fourth and final problem. You try. What are the vertices, foci, and asymptotes of the hyperbola with the equation vertices, foci, and asymptotes of the hyperbola with equation 9x squared minus 4y squared equals 36. Okay, so I'm going to let you do that. Hit pause and then come back. Come back. So if you did this one out correctly, you should have gotten vertices plus or minus 2, 0. Foci plus or minus 13, 0. Asymptotes should be y equals plus or minus 3/2 x. And, oh, I forgot to say, I was going to ask you also whether it was a horizontal or a vertical hyperbola. So maybe you can figure that out. Hit pause, figure that out, and then come back, and I'll tell you in 1 second. Welcome back. All right, horizontal. How could I tell? Well, the foci are on the x-axis. That would be one way. The vertices are also on the x-axis. That would be another way. Okay, and that is it. If you have questions, please bring them to class. And I look forward to seeing you all soon. Thank you. Bye-bye.